Welcome at Ask the Professor for this MOOC, new release. I'm really happy to see you all. Welcome, and I really enjoy your interactive reactions, questions, and also please, when you have cases or questions, put them on the forum, on the online parts in this MOOC. That will help a lot, and also you can help each other as well, because I cannot all answer you all and I can give you instructions or ideas, but please help each other and give answers to each other and be active. That's important. So let's start with the questions. There was a question about waves and what is the impact on waves and how it works. But I think it's very clear written down at the MOOC what we mentioned and what we mean with waves. When we look at the rail bar here in the laboratory of the TU Delft, we have some rail imballast and sleepers. We can explain what we do, because normally these rail bars are pre-stressed because we have a continuously welded track. So when there is weather conditions, more sun or cold, you get pre-stressed rail bars, and that means you get real problems when you have too stiff rail bar and when you have low weight of your vehicles. That means you have a very stiff rail bar, and then when it is pre-stressed and you hit it by a low weight vehicle, you will have an input and some vibrations, and you can hit this one, and then you can get reaction responses back of the rail and of the construction. And then when you have the wrong frequency or an eigenfrequency, that will give some real problems when you drive over of this. And then the real question is coming: what can you do about it when you have these problems and when you get corrugation, for example? You could change some things, but you need to take into account you have mass, and mass is really important in this area. You cannot make a tram wagon or coaches more weight, because then you need more weight inside, but that's not, then you change the construction. But you can also think about what can we do with the speed. And that is really the issue over here. When you don't like to change the full construction and you know to pre-stress because of the weather or what other conditions, you can think about what can I do with the speed. So that could be a nice calculation for you. And a nice question was about a real innovative idea about the rolling pantograph. And I'm standing here at the university, at our laboratory, and we have a prototype here. So when you go down here, you see this roller, and you see also the construction, how you could manage it to put on the top of the rail, top of the train, sorry. It's upside down. You see it with this side guidance, you could say, for the power line. And so that is upside down. You put it on the pantograph. So you remove the old one. You could say the old one is like here. You see this. This is the carbon one. Everybody knows. Very cheap. This is also very cheap. It works. We tested here in the lab with more than 250 kilometers an hour. But still, it is really an innovative new thing. It is not sliding, it's rolling, and rolling means you have to prove it. It is safe, you have to prove it. It is more cost effective. It must be also robust for a long run. So the most critical part now is how to make this one happen from a low TRL level to a higher one that we really can prove it works. And that's the problem with this roller rig, because here in the lab we are more or less finished, it works, but now it has to go on the train, make a lot of kilometers, make it safe, and prove it will be robust for the future. So let's see. The next question is about what can we do and how to use, for example, sensors in track and to monitor all kinds of things inside the track, but also from the rolling stock. And we have several things of sensoring. So you can put it on board, you can put it in track. And here in our lab we also have some ideas with strength gauges. So let's see and look what is happening here. So you see, for example, when you like to know, this is for a tram rail, and you like to know what is really ongoing inside the stresses inside this part from the top of rail and the foot. You can put some strength gauges. You glue them on, you can monitor them online with your laptop and see what is really happening when the train is passing over. And because of vibrations, as I also explained about waves, you can also see what that means when the train is running over. And you can measure, for example, differences in this strength and also the stresses when the train is passing by. And you can also optimize, for example, in this way, what is the critical velocity when you have problems with these waves in the early question. So make your puzzle. Last question of today was about what is it about the golden era in the USA, for example, when we have much more railway kilometers as we have today. And that's depending on what is really first in the revolution of industry. And I think when we started with the steam engine, then everybody was really excited, because why not using a steam locomotive to go on and do your transport all over the world, you could say, but also in the USA. Later on, you get the combustion engine, and then you get freight transport by trucks and cars, etc. And that was also nice, because then you get more flexible, and you could make your own journey on the spot. So that's also a balance. Now we get another issue, because we have CO2 reduction, and we like to do this. And then you can have a switch to go back to the train and freight transport, for example, because that's really more nice for your CO2 reduction and footprint than we do this with the combustion engines and trucks. So make your choice, and I think for the future it will be changing. Get more and more train transport like here in Europe. That's it for today. I really hope you enjoyed, you learned something. Please exchange when I cannot touch everything, of course, so when you have really details in your own country, feel free to post to each other, upload your ideas and things, what you have in mind on the forum areas on this online education MOOC. Good luck. See you next time in the next round of Ask the Professor. I really look forward to your questions, and make me curious, and send and upload your ideas. Thank you.